Azure Cost Optimization, 9 levers engineering teams use to cut cloud bills. Welcome back. Today's topic is Azure Cost Optimization, 9 levers engineering teams use to cut cloud bills. We'll cover what you actually need to know about Azure Cost Optimization. Next up, how do I reduce Azure costs? Azure Cost Optimization starts with visibility. You cannot cut what you cannot see. The first step is enabling Azure Cost Management plus billing and reviewing the cost breakdown by resource group, subscription, and tag. Once you have that baseline, the 9 levers below give you a systematic path through the biggest saving opportunities, ordered roughly from fastest wins to longer-term structural changes. The 9 Azure Cost Optimization levers are: right-sizing compute, committing with reservations, removing idle resources, implementing storage tiering, optimizing network egress, applying Azure Hybrid Benefit, automating dev/test scheduling, governing with FinOps tagging, and modernizing legacy workloads. Work through them in order, and most mid-market organizations will find 30 to 50% of their current bill is recoverable. Next up, lever 1, right-size your compute resources. Over-provisioned VMs are the single most common source of Azure waste. Teams pick VM sizes during initial deployment based on peak estimates, then never revisit them. A VM running at 8% average CPU utilization for 12 months is a straightforward saving waiting to be claimed. Azure Advisor surfaces right-sizing recommendations automatically. For any VM with less than 5% average CPU and low network activity over 14 days, Advisor recommends a smaller SKU and estimates the monthly saving directly in the portal. In practice, most teams find 20 to 30% of their VM fleet can be downsized by at least one size tier without any noticeable application impact. Run the assessment on a rolling 30-day window rather than a 7-day snapshot to avoid undersizing workloads with weekly batch spikes. Static VM sizes make sense for truly predictable workloads, but most web-facing services see traffic patterns that follow a daily or weekly rhythm. Azure Virtual Machine Scale Sets with schedule-based or metric-based autoscaling cut the baseline cost without requiring manual intervention. Pair autoscaling with solid Azure Pipelines YAML deployment workflow so scale-down windows don't conflict with deployment schedules. Let's talk about now, lever 2, commit with reserved instances and savings plans. Pay-as-you-go pricing is the most expensive way to run predictable workloads. For any resource that runs continuously, reserved instances and Azure savings plans cut the effective hourly rate by 20 to 72% compared to on-demand pricing. This is often the lever with the highest absolute dollar saving for mature Azure environments. 1-year reserved instances typically save 30 to 40% versus pay-as-you-go. 3-year terms save 50 to 72%. The right choice depends on workload stability. For production databases and application servers with no planned migration, 3-year terms pay off quickly. For workloads tied to a specific project, 1-year terms keep options open. Reserved instances lock savings to a specific SKU and region. Savings plans apply across eligible compute regardless of VM size or region, which suits teams that resize frequently or operate across multiple regions. For Azure infrastructure assessment purposes, run a 30-day usage analysis before committing to either product. An Azure architecture review will often reveal that a mix of both, RIs for stable core workloads, savings plans for variable compute, delivers the best coverage without overcommitting. Next up, lever 3, eliminate idle and orphaned resources. Orphaned resources accumulate silently. A developer spins up a VM for testing, the VM gets deleted, but the associated managed disk, public IP address, and network interface remain, each billing independently. According to Microsoft's Cost Management Best Practices documentation, organizations without active governance typically waste 10 to 15% of their cloud spend on resources that serve no live workload. The main categories: unattached managed disks, and used public IP addresses, empty load balancers, snapshots older than 90 days, and unattached network interfaces. Azure Advisor flags most of these. For a thorough sweep across large environments, combine Advisor with Azure Resource Graph queries that search across all subscriptions simultaneously and export results to a spreadsheet for triage. Azure Advisor runs daily and surfaces idle resource recommendations with estimated monthly savings. Set up weekly cost management exports to a storage account, then build a cost visibility dashboard to track orphan counts over time. This is one area where Power BI Consulting Services delivers immediate ROI. A well-built FinOps dashboard pays for itself within the first month of operation by making waste visible to the teams responsible for it. Let's talk about now. Lever 4, implement storage tiering and lifecycle policies. Azure Blob Storage has 4 access tiers: Premium, Hot, Cool, and Archive. Most teams set everything to Hot at creation time and never revisit it. The cost difference between Hot and Archive is roughly 20x per GB stored. For data older than 90 days that gets accessed less than once a month, the saving is substantial. Hot storage costs approximately $0.018/GB/month and suits frequently accessed data. Cool drops to around $0.01/GB/month for data that's needed occasionally but still requires relatively fast retrieval. Archive costs approximately $0.000099/GB/month, less than a tenth of a cent per gigabyte, at the cost of several hours for rehydration. Archive is well suited to compliance data, historical logs, and old backups that must be retained but are rarely read. Azure Storage Lifecycle Management policies move blobs between tiers automatically based on last modified date or last access time. A typical policy moves blobs to Cool after 30 days and Archive after 90 days. It runs without any operational overhead once configured. For teams managing large backup repositories or audit logs as part of Azure Cloud Migration Services, lifecycle policies are often the fastest single configuration change that produces measurable monthly savings. Next up, now, Lever 5, optimize network and data egress costs. Data transfer costs catch engineering teams off guard because they don't show up in the compute or storage line items. Inbound data to Azure is free. Outbound data leaving Azure to the internet, and data moving between Azure regions, incurs charges. For data-intensive applications, egress can represent 15 to 25% of total Azure spend. The most reliable fix is co-locating dependent services in the same Azure region. If your application server runs in UK South and your database sits in West Europe, every query incurs cross-region transfer charges. An Azure Architecture review will surface these anti-patterns quickly. When co-location isn't feasible, Azure ExpressRoute private peering often costs less than internet egress for high-volume scenarios once the circuit commitment is factored in over a 12-month period. Azure CDN and Azure Front Door cache content at edge locations, reducing origin server responses and the associated data transfer charges. For web applications serving static assets globally, CDN alone can cut egress bills by 40 to 60%. Azure Front Door adds intelligent routing and WAF capabilities on top of CDN, which is directly relevant if you're simultaneously running an Azure Security Assessment to harden your application perimeter alongside the cost reduction work. Let's talk about now, Lever 6, apply Azure Hybrid Benefit and reuse licenses. Azure Hybrid Benefit lets organizations apply existing Windows Server and SQL Server licenses covered by software assurance to Azure VMs, removing the license component from the compute rate. For a standard D4S_V3 running Windows Server, AHB cuts the hourly rate by approximately 40%. AHB applies to Windows Server VMs and to Azure SQL Database, SQL Managed Instance, and SQL Server on Azure VMs. For organizations with significant SQL Server licensing, moving to Azure SQL with Hybrid Benefit as part of a lift and shift to Azure migration is one of the highest ROI moves in the entire engagement. The saving compounds with reserved instances, combining AHB and a 3-year reservation on SQL Managed Instance can reduce costs by over 80% compared to on-demand licensing. Windows Server 2012/2012 R2 and SQL Server 2012 reached end of support in October 2023. Running these on Azure provides extended security updates at no additional charge, a saving compared to purchasing ESUs for on-premises deployments. This is one concrete financial argument for the migrate on-premise to Azure decision for organizations still running end-of-life workloads on aging hardware. Now, Lever 7, automate dev/test workload scheduling. Development and test environments don't need to run around the clock. A dev VM running during business hours only consumes roughly 40% of the hours it would otherwise accumulate. Across a team of 20 developers, the saving is significant with near zero engineering effort to implement. Azure DevTest Labs and the native VM auto shutdown feature allow schedule-based shutdown with a single configuration change per VM. For AKS dev clusters, scheduled node pool scaling to 0 outside business hours achieves the same effect at the Kubernetes layer. The honest caveat: auto shutdown only delivers savings if developers don't simply restart VMs manually when they find them off. Policy enforcement through Power Platform governance principles, requiring approval to override schedules, is what makes the savings stick across a team. Azure Dev/Test subscriptions provide reduced rates for Visual Studio subscribers. Windows VMs on Dev/Test subscriptions carry no Windows license charge, and several PaaS services run at a discount. If your team runs Dev/Test workloads on a production subscription today, migrating them to a dedicated Dev/Test subscription can cut those specific costs by 40 to 60% with no architectural changes required. Now, next up, Lever 8, govern costs with FinOps tagging and budgets. Without tagging, Azure Cost Management shows you what you're spending but not who is responsible for it. Showback, attributing costs to teams or products, and chargeback are both impossible without consistent resource tagging. This lever doesn't cut costs directly. It creates the accountability structure that makes all other levers sustainable. A workable tagging schema covers at minimum, or, and. Enforcing tags at resource creation through Azure Policy ensures every new resource carries the required tags. Retrofitting existing resources requires a one-time cleanup run. Most Azure Managed Services provider engagements include resource tagging remediation as a day one activity alongside the initial Azure infrastructure assessment. Azure budgets send alerts when spend approaches a defined threshold. Set a budget at both the subscription level and the resource group level for critical workloads. Alert at 80% and 100% of the monthly target, with action groups that notify the responsible team lead via email or Teams. For proactive cost control, combine budgets with Azure policy rules that block resource creation in subscriptions that have already hit their monthly cap, a pattern that our Power Automate consulting work often extends into automated approval workflows for over-budget exceptions. Next up, now, Lever 9, modernize legacy workloads for cloud-native efficiency. Lift and shift migrations get workloads to Azure quickly, but they preserve the cost model of on-premises infrastructure. A VM-based application moved as is runs more reliably in the cloud, but it doesn't become cheaper per unit of work. Cloud-native architectures, containers, serverless, managed PaaS, change the cost model fundamentally by charging only for what you actually use. Lift and shift makes sense when speed to cloud is the priority, meeting a data center exit date, avoiding a hardware refresh cycle, or enabling a hybrid cloud Azure setup while modernization happens in parallel. The cost optimization opportunity then comes in Phase 2, replatforming to App Service or AKS, refactoring event-driven workloads to Azure Functions, and replacing self-managed databases with Azure SQL or Cosmos DB. Our guide on legacy app modernization covers the rewrite versus refactor decision in detail, including the cost thresholds that make each approach viable. An application containerized on AKS with autoscaling and bin packing typically consumes 30 to 50% less compute than the equivalent VM deployment. Azure Functions charges only for execution time, ideal for event-driven or intermittent workloads that would otherwise require a dedicated VM running at low utilization. For Azure App Modernization projects, combining containers, managed databases, and storage tiering routinely delivers 40 to 50% total cost reduction compared to the migrated but not optimized baseline. See our .NET Application Modernization Roadmap for a 5-phase implementation approach that balances speed with cost outcomes. Next up, how an Azure migration partner accelerates cost reduction. Implementing all 9 levers internally takes time and expertise that most engineering teams can't spare from their core product roadmap. An experienced Azure migration partner brings 3 things: a structured Azure infrastructure assessment that identifies the highest value opportunities in your specific environment, engineering capacity to implement changes without disrupting production workloads, and ongoing governance through an Azure Managed Services provider model that keeps savings from eroding over time. Q Services is a Microsoft-certified solutions partner with 500-plus Azure and Microsoft platform projects completed since 2014. Our Azure Cost Optimization consulting engagements start with a free Azure cost review that maps your current spend against all 9 levers and produces a prioritized action plan with estimated savings per item. We apply human-in-the-loop governance to ensure human approval at every deployment stage during the remediation process, so no change goes live without your team's sign-off. Our approach to AI agent governance applies the same principle to any AI-augmented workflows we build alongside the infrastructure work. For teams evaluating Azure's AI capabilities as part of a broader platform decision, the Azure AI Foundry versus AWS Bedrock comparison covers where Azure's cost model competes strongly for enterprise AI workloads. Let's talk about next up, conclusion. Azure cost optimization is an engineering discipline, not a one-time project. The 9 levers covered here address the most common sources of Azure overspend: oversized compute, uncommitted spend, idle resources, untired storage, unnecessary egress, unused licenses, always-on dev environments, missing governance, and unmodernized workloads. Working through them systematically, most organizations recover 30 to 50% of their current Azure bill within 2 to 3 sprints. The first step is always visibility. Enable Azure cost management, tag your resources, and run an honest audit against each lever. If your team would rather skip straight to the savings, book a free Azure cost review with our team. As a Microsoft Azure consulting company with deep expertise across Azure Cloud Migration Services, Azure Managed Services Provider Support, and Azure App Modernization, Q Services will show you exactly where the budget is going and what to fix this sprint.